This video is notes on how to graph when given an equation of a line. When you're given an equation of the line, as in number 1, y equals negative 4x minus 7, we first want to identify the rate of change, or the slope, which is going to be the negative 4, 1/4. Remember, m and x are always going to be side by side. We also need to identify the b value, the initial value, the y-intercept. In this case, it's a negative 7. When you're graphing lines, graph the initial value first. So we're going to graph negative 7. The y-intercept will always go on that vertical y-axis. After you graph the y-intercept, then you can graph the slope, or the rate of change, second. Because it's negative, we're going to go down 1, and we're always going to go to the right 4. So we start at negative 7 because that's our initial value. We go down 1, that puts us at negative 8, and then right 4, 1, 2, 3, 4, and we put a new point. We do that again. Starting from that point, we go down 1, and then right 4, 1, 2, 3, 4. We cannot go any further. We can go down 1, but we cannot go right 4. That would take us off the graph. So we have this part of our line so far. However, we want the line to go the opposite direction too. So putting our pencil back at negative 7, go up 1 and over 4. 1, 2, 3, 4, in order to continue the line across the graph. All the way to the edge. So continue going up 1 and over 4. 1, 2, 3, 4. I can't go any farther because if I go up 1 and over 4, it would take me off the graph. So we can just extend our line all the way across. Always make sure that your line goes across the graph. For problem number 2, we're given the equation y equals negative x minus 7. First step is to identify the rate of change, or the slope. Remember, m and x are always side by side, so we have a negative x. If there is no number, we know it's an understood 1. So that negative 1 is going to be our slope. The initial value, or the y-intercept, is going to be the minus 7. When you are graphing your equation, graph the initial value first, the negative 7. And it will always go on the y-axis. We put a point at negative 7. Then we can graph our slope second. Because it's a whole number, it's a negative, so we're going to go down 1. Negative is down. Down 1. And then we don't have a denominator, so we're just going to go right 1. Putting our pencil at negative 7 where we start, we're going to go down 1 and right 1 and put a point. And continue doing that, down 1 and right 1. Continue again, down 1 and right 1 till you reach the edge of the graph. And you can connect your dots. There is half of our line. We want to continue that pattern going the opposite direction, so that way our line extends all the way across the graph. So going back to negative 7, we go up 1 and over 1. Up 1, over 1. Up 1, over 1. We keep doing this pattern of up 1 and over 1 all the way across the graph, so that way we can reach both edges. And once you reach the edge, you can go ahead and connect your dots. And now your line extends all the way across the graph. For number 3, we have the equation y equals x plus 4. First step is to identify the slope, or the rate of change, m. There is no number in front of x, so we know that that's going to be an understood 1. M is a positive 1. B, the initial value, or the y-intercept is going to be our positive 4. When it comes to actually graphing the equation, you graph the initial value, the y-intercept, first. So we're going to put a point at positive 4 on the y-axis. When it comes to graphing the rate of change, or the slope, we graph that second. It's a positive 1, so positive means we're going to go up. Because it's not a fraction, we're just going to go to the right 1. So putting your pencil at 4, where our initial value starts, we're going to go up 1 and right 1 and put a point. Up 1 and right 1 to continue that pattern. Up 1 and right 1. We continue this pattern of up 1 and right 1 all the way until we reach the edge of the graph. And then you can connect your dots. The last piece we need to do is to continue our line across the other half of the graph. So we're going to put our pencil back at 4, and we're going to go the opposite way. Down 1 and over 1. Down 1, over 1. Down 1, over 1. The same amount, just backwards. So that way our line extends all the way across to both edges. Down 1 and over 1, all the way to the edge. Once you reach the edge, you can connect your dots, and you should have a line that reaches all the way across your graph. With problem number 4, we have the equation y equals 2x minus 2. We start by identifying our rate of change, or the slope. The mx always goes together, and in this problem we have a 2x together, so our rate of change is 2. Our initial value, or the y-intercept, which is b, is going to be towards the back, which is a minus 2. When we are graphing our equations, the b value, the initial value, or the y-intercept, always gets graphed first. So put a point at -2 on your y-axis. The rate of change, or the slope, is always graphed second. Because it's a positive 2, positive means we're going to go up 2, but because we don't have a denominator, we're just going to go to the right 1. So putting our pencil at -2 where we're starting, we go up 2 and over 1 to make our new point. And we're going to do that again, up 2 and over 1. Up 2, right 1. And we continue this pattern of up 2, right 1 until we reach the edge of the graph. Once you reach the edge, you can go ahead and draw your line and connect your dots. The last section that we need to do is the other half of the graph. So we put our pencil back at -2 where we started, and we're going to go the opposite direction, down 2 and over 1. We continue doing this so that way our line crosses the graph in its entirety, connecting our dots along the way. For problem number 5, we have the equation y equals 1/5 x plus 4. First step is to identify our rate of change, or our slope, which is letter m. M and x always go side by side, and so m, our rate of change, is 1/5. Our b value is the initial value, or the y-intercept, and it's always going to be at the end, so that's going to be the +4, the positive 4. When it comes to graphing the equation, we start by graphing the initial value first, the starting point. So put a point at +4 on the y-axis. Step 2 is to graph our slope. We have a positive 1/5. Positive means up. So we're going to go up 1 and right 5 with our fraction. So putting our pencil at 4 where we start, we're going to go up 1 and right 5 and put our new point. And we're going to do that again. Go up 1 and right 5 until you reach the edge of the graph. Then you can connect your dots. The last step is to continue that pattern across the other side of the graph, meaning we have to go backwards. Put your pencil back at 4 where you start, but this time go down 1 and over 5. Go down 1 and over 5, continuing that pattern until you reach the edge of your graph. Connect your dots, and your line now spans the entirety of the graph. For problem number 6, we have the equation y equals negative 3x plus 4. We're going to start by identifying our m value, which is the rate of change or the slope. M and x are always side by side, so m is going to be our value of negative 3. Our b value, which is the initial value or the y-intercept, is going to be towards the back, which is our positive 4. When it comes to graphing the equation, we start by graphing the initial value. The y-intercept goes first. So we're going to put a point at positive 4 on the y-axis. Graphing the slope, or the rate of change, comes second. Because we have a negative 3 for our slope, negative is going to mean that we're going to move down 3. Because we don't have a fraction, we're just going to go to the right 1. So put your pencil at 4 where we're starting. We're going to go down 3 and right 1 for our new point. We're going to do that again. Go down 3 and right 1. Down 3, right 1. Continuing that pattern of down 3, right 1 until you reach the edge of the graph. That last point took me off the graph slightly. That's okay. You can just kind of estimate where that last point would go. And then your last step is to complete the graph on the other side, meaning we have to work backwards. We put our pencil back at 4 where we started, and this time we're going to go the opposite direction, up 3 and over 1 to continue the pattern. Up 3 and over 1, so that way we can reach both edges. Connect your dots and your line should span the entire graph. For problem number 7, we have the equation x equals negative 4. Now, when we have the equation x equals negative 4, it is not written in slope-intercept form, y equals mx plus b, meaning our slope is undefined. It's non-answerable. It's not possible to solve. And for our initial value, the y-intercept, there is no y-intercept. Again, if you have an x equals equation, it means that you have an unsolvable equation. So we have an undefined slope and no y-intercept. The only piece of information that this gives us is that the x-intercept is negative 4. So what we're going to do is on the x-axis, we're going to put a point at negative 4. Now, because we don't have a slope, we can't go up or down, we can't go side to side, our line is a vertical line that runs through the point negative 4. It stays straight up and down, it does not go side to side, and it runs through the point given in the equation, negative 4. That is our graphed line. For our last problem, number 8, we have the equation y equals 1. In relation to slope-intercept form of y equals mx plus b, this equation would be written as y equals 0x plus b. You'll notice that in the equation y equals 1, there is no mx value. Because there is no mx value, our rate of change or our slope is 0. The initial value would be the 1. That would be the plus b that's at the end of the equation. So when it comes time to graph it, we graph the b value first. So we're going to graph positive 1 on the y-axis. We graph the rate of change second, but because it's 0, it means we can't go up or down. We just go 0, meaning our line is a straight horizontal line. We cannot go up, we cannot go down because the rate of change is 0. The straight horizontal line located at 1 is our final graph.